Video number 153, finding all 6 trig function values given one of them. Let's start off, tangent theta equals square root 3, and the angles in quadrant 3. Find all 6 trig function values. Let's start off locating quadrant 3, here it is. We also know that tangent is opposite over adjacent. And we also know that root 3 is approximately 1.7. Which means the opposite's taller than the adjacent. So it's fair to say that this triangle's taller. Excuse me, that's quadrant 2. Quadrant 3. So this triangle is definitely taller. So we're going to go this way. We're going to call this root 3. Call this a 1. Right angle. Now, in order to find these 6 trig function values, we need to find the hypotenuse. So we're going to need to do the Pythagorean theorem. So we're going to do 1 squared plus root 3 squared equals c squared. That's going to give us 3 and a 1 square root. That gives us 2. So this is 2 here. Now, find all 6 trig function values. Well, we know that sine would then be opposite over hypotenuse. So that would be root 3 over 2. Okay. Cosine would be adjacent over hypotenuse. That would be 1/2. And then tangent, they already told us that that was definitely root 3. Then cosecant would just simply be the inverse of sine. So we're going to go 2 over root 3, which gives us 2 root 3 over 3 for simplifying or rationalizing the denominator. Secant would be just 2 over 1, and then cotangent would obviously be 1 over root 3, which becomes root 3 over 3. Okay, now we're going to go through and take care of business with the negatives. This was definitely a negative x value and a negative y value. In order to get to this position, we need to go negative x and negative y, which means sine's negative, cosine's negative, which means tangent's what? Positive. If this is negative, of course, so is the cosecant, and if cosine's negative, of course, so is secant. So there you have it. Positive tangent, positive cotangent. All right, next one. Cosecant theta equals negative 3, and tangent theta is less than 0, meaning tangent theta is negative. All right, so where is tangent negative? All right, tangent's negative, well, definitely not here. That's quadrant 1. And then not here because tangent sine over cosine, this is both negatives, therefore tangent's going to be positive. So we're talking about reference angles in quadrant 2 and quadrant 4. Let's take a look. What is cosecant again? Cosecant is definitely the inverse of sine. Therefore, cosecant is not opposite over hypotenuse. It's hypotenuse over opposite. So we're taking a look at a hypotenuse of 3 and an opposite of 1. Hypotenuse 3, opposite 1. So we're looking at something like this. This would be a 3 to 1 relationship. All right, because there's theta. 3 to 1. Okay, then we're going to do the Pythagorean theorem again. 1 squared plus, this time, x squared equals 3 squared. Therefore, x squared is 8 because that's a 9, that's a 1. Square root will give you root 8, or in other words, 2 root 2. So 2 root 2 is the x value. And then now what we're going to do is we're going to take sine. We know that sine is definitely 1/3. Cosine is definitely 2 root 2 over 3. Okay. And then tangent, they tell us. No, tangent, they don't tell us. We can figure it out. It's 1 over, opposite's 1 over 2 root 2. Alright. We're going to rationalize this denominator by multiplying by root 2 over root 2. So that's going to give us square root 2 over 2 times 2, which will be, right, this is a 2 here. Multiply this, that'll be a 2, so that'll be a 4. Root 2 over 4. Okay? Next, cosecant, inverse of sine, 3. Secant, inverse cosine, that'll be 3 over 2 root 2. Then we're going to go through and multiply by root 2 over root 2. That's multiplying by 1. Alright, we got 3 root 2 over 4. And then cotangent would then definitely be the inverse of tangent. Now don't flip this over because that's going to have an irrational number in the denominator. Flip over the original. That's just simply 2 root 2. Then go through and double check your negatives. Double check your negatives here. We want to make sure that, okay, so actually there's going to be a couple different answers because we could have had a negative x with a positive y, or we could have had a positive x with a negative y. So actually, we are going to have a couple different answers. Let's take our time here and check it out. 1/3 opposite over hypotenuse could have been positive 1/3. It also could have been negative 1/3. So actually, it could be plus or minus. All right. Cosine, it could have been negative 2 root 2 over 3 or positive 2 root 2 over 3. So it's plus or minus. Okay. Tangent, let's see if that one could have been negative. Let's see. Actually, no, because... Actually, well, yes, because they want tangent theta to definitely be negative. So, it's negative no matter how you do it, right? Opposite over adjacent, that's negative. Opposite over adjacent. So, it's definitely just simply negative root 2 over 4. All right. If this is plus or minus, this is obviously plus or minus. If that's plus or minus, so is this. And then 2 root 2, that will still be negative because instead of it being 1 over 2 root 2, it'll be 2 root 2 over 1, and they both have the 1 negative. So no matter what, negative for that one. It's kind of an interesting problem. So, all right. Any questions or concerns, send me an email. And, of course, good times.